Hello everyone, my name is Sumit Maheshwari, working as an assistant professor in ABS Engineering College. Today I'm delivering a lecture on numericals of delta connection three-phase AC system, which is the topic of fundamental of electrical engineering subject. So first of all, we discuss the numerical. A balanced delta connected load of 8 plus J6 ohm per phase is connected to a three-phase 230-volt supply. Find the line current, power factor, and three-phase complex power. So first of all, we make a delta connection and understand the relationship between phase and line quantities. These are our three phases R, Y, B at supply end, and this is our delta connection. These are our line voltages, and voltage across these three phases are Vp. So in last lecture, we can discuss the relationship between line and phase voltages in delta connection. That is, VL is equal to Vp. Here, the currents, if this is IR, this is IY, and this is IB, and the current flowing through these three phases are IP. So the relationship between line and phase current is IL is equal to root 3 times of IP. This is the relationship used in this numerical. After that, we have the some given values. Supply voltages VL 230 volt is given, and Z phase, that is 8 plus J6. Here 8 is Rp in ohm and 6 is reactance Xp of this coil. The resultant of this rectangular form in term of polar form is 10 angle 36.87 degree. You can solve it by using calculator. So here mod of Zp is 10 ohm. If we have VL is equal to Vp, then the value of Vp is now 230 volt. For calculating the IP, we can write here Vp upon Zp. So value of Vp is 230 angle 0 degree and Zp 10 angle 36.87 degree. After calculating, it is near about 23 and at an angle minus K 36.87 degree. So the value of IP is 23 angle minus K 36.87. So we can calculate the IL. So IL is equal to root 3 times of IP, and the value of IP is magnitude is 23. So after calculating, it is 39.84 ampere. Now we are talking about the active, reactive, and apparent power. But before calculating the complex power, we can discuss the power factor cos phi, that is Rp upon Zp. Rp is 8, Zp mod of Zp is 10, that is 0.8, and there are 3 coils. So the power factor is in lagging. Or we have Vp at an angle 0 degree, and we are calculating IP, that is 23, with an angle minus K 36.87 degree. So here current is lagging, and cos phi is cosine angle between voltage and current. So cosine angle 36.87 degree. So after calculating, it is 0.8. Now we are talking about the active, reactive, and apparent power. Three-phase active power that is called P3 phase is thrice of Vp Ip cos phi, or thrice of Ip square Rp. We are using here this formula. You can use any of them. Thrice of Vp, that is 230, Ip, that is 23, cos phi 0.8. We can solve it by using calculator, and it is 12,696 volt. Sorry, watt, or we can say 12.696 kilowatt. Similarly, three-phase reactive power that is Q three-phase thrice of VPIP sin phi, or the secondary formula is thrice of IP square XP. We are using thrice of VP IP sine phi, that is 230, IP again 23, and sine phi is 0.6. After calculating, it is around 9522 volt ampere reactive, or 9.52 kVAR. Similarly, for three-phase apparent power, S three-phase, that is thrice of VP IP which is thrice of 230 into 23. After calculating, it is 15870 volt ampere, or 15.8 kVA. So in such a way, you can calculate active, reactive, and apparent power. There is an alternative formula, thrice of IP square ZP, to calculate apparent power. So in such a way, we can find out the line current and phase current, line power and phase power, power factor and three-phase complex power of this delta connected load of 230 volt. In upcoming lectures, we can discuss some more problems on this three-phase AC system. This numerical is taken from J.B. Gupta.